In this section, we're going to be solving polynomial equations. So in this case right here, we see a quadratic equation, quad meaning that we have a base of x raised to the second power. Again, if it's an equation, this is f of x, so a function of x. This is the same thing as saying y. So f of x is the same thing as saying y. When we graph a quadratic equation, we get what's called a parabola, which is again a curved line here. Two things, a possibility of three things can happen. We can have an equation that looks like this, or a parabola that looks like this, where it'll intersect the x-axis twice. When we are solving for the quadratic equation, we are solving for the x-intercepts. As a review, remember that the x-intercepts have x values here where they cross the x-axis, and because of where they're located on the coordinate plane, the y-coordinate is 0. Okay, so this is one scenario that will happen when we graph a parabola. Another scenario will be that it intersects the x-axis only once, so therefore this would have a 1 solution. And then this third one over here off to the side is an example of where the quadratic equation will not intersect the x-axis at all, so therefore it would have a no solution. Now the reason why we're going over these is because there's applications of where these things will happen. So for example, just because this is turned upside down, it still represents a parabola. This is some place where we could show where something has been thrown up into the air, and if we play sports or know of sports, it will come to a peak and then gravity will start to pull that object back down. So an example of something like this would be like kicking a kickball. So here this is ground 0 times 0, so that's where we're at the origin here is 0, 0. The ball will be kicked and the y-axis shows how high it's going to go, but also it'll show the time lapse on how long it will take for it to reach its peak, and also how long it'll take for it to come back and hit ground 0. Back in a previous section, we learned about the cubic function, so something that is being raised to the third power looks something like this, where it looks like a snake, or an upside down S, or a sideways S. So there are three possibilities here with a quadratic or with a cubic function. It could cross the intersection, the x-axis once. Here we see that it could cross it twice. Here we see that it could cross it 3 times, and then of course it could be raised something like this, where it doesn't cross it anywhere on the x-axis. So in this case, 4 different possibilities where it crosses it once, twice, 3 times, and then no times. So that would be a no solution on that one. So here we see an example of a quadratic and a cubic here. So since we are trying to find the x-intercepts, we need to find out when this equation, so if it's an equation, it's going to be equal to y, or it could be equal to f of x, is 0. So all we have to do is rewrite these so that the y is 0 or the f of x is 0. For the past week or two, we have been concentrating on how to factor quadratic equations. When we factor quadratic equations, we get 2 binomials that are being multiplied to each other. And then recently we went over how to factor cubic functions, which look like this, and again set it equal to 0. So we talked about in class how if the entire equation is equal to 0, it is fair to say that either this full binomial is 0 or this binomial is 0, because 0 times something has to give us 0. Same thing can be said down here. Either this has to be equal to 0 or this has to be equal to 0. For example, if we have this quadratic equation right here, x squared minus 81, when we factor that, we get x plus 9, x minus 9 equals 0. So that means that either this binomial or this binomial has to be equal to 0. Since we don't know which one, we have to assume either or, so that means we need to find out what value would make this binomial 0 and what value would make this binomial 0, which means that I have to set both of them equal to 0 to find out what that x value would be. So the x value that would make this one 0 would be a -9. And that was again just by solving for x. On the right hand side, if I add 9 to both sides, I get x equals 9. So that means that this equation right here, this x squared minus 81, has an x-intercept at -9 and +9. So if you were asked to just list these in my math lab, you could go ahead and separate them by commas. But if they were asking you to write them as an ordered pair, you would need to write them as -9, 0. Again, this is the x-coordinate. The y-coordinate is always 0 since it's an x-intercept. And then +9, 0. Okay, in this example we have 7x squared equals 56x. So in order to solve this, this side needs to be 0. You always want to try to keep your x squared positive, so we wouldn't want to move the 7x squared to the right hand side because that would then change it into a -7x squared. So we need to have a 0. There always has to be a 0 in order to solve. So we subtract 5x on both sides. Or sorry, 56x. So we get 7x squared minus 56x equals 0. Okay, we need to factor this, so I notice that there is a GCF of 7 and x. So we get x minus 8. We factor. That means that we have to set these both equal to 0. So I have 7x equals 0. Divide both sides by 7, so x equals 0. And then I have to take my x minus 8 equals 0, add 8 to both sides, and I get x equals 8. So my two intercepts, or two x values, are 0 and 8. Again, if you have to list them, just put 0, 8. If you have to write them as an ordered pair, we would write this as 0, 0, and 8, 0. In this example here on the left hand side we have two binomials that are being multiplied to each other, and then a 6x on the right hand side. Now we do have to move this x to the other side here. In order to do that, we need to actually distribute this first. So we can't move 6x to the left hand side and combine it with any like terms until we multiply this out. So it sounds a little counterproductive, again, because we want to factor this to get our zeros, but we can't do that until we have the left-hand side and the right-hand side combined. So when we do this, we get 5x squared. 5x times a positive 2 is 10x. A -1 times x is a -x. A -1 times a positive 2 is a -2 equals 6x. Combine like terms, we get 5x plus 9x minus 2 equals 6x. Bring that 6x over, and we get 5x squared plus 3x minus 2 equals 0. So we have a trinomial, a quadratic here. We need to factor this, so I need to factor this using the AC method. I know that because there's a 5 in front of the x squared. If this were just a basic x squared, I could factor this a little bit easily, so we have to take a couple of extra steps. So the AC method requires us to take the a value and our c value, multiply that together, so we get a -10. I need to figure out factors of 10 that subtract out, again subtract because it's a negative, to +3, which is our b right here. So if I have a +5 and a -2, +5 and a -2, I will get that +3x that I need. So what I am going to do is take these +5 and this -2, put x's on them, because what we're going to do is take this +5x and this -2x and simplify it or substitute it into our equation where the 3x was here. So I'm going to rewrite this: 5x squared plus 5x minus 2x minus 2 equals 0. Okay, again, using the term loosely, quad, We have 4 terms here, so this is going to require us to do factor by grouping. So we do this by looking at the first 2 and factoring out whatever we can, which here we can see that we have a GCF of 5x. So we get x plus 1. Since this starts with the negative 2, we have to factor out the negative along with the 2, which is the GCF. So we get x plus 1 equals 0. Almost there. Notice now that we have our GCF in this case is x plus 1, so we're going to take that x plus 1 and factor it out, and we're left with 5x minus 2 equals 0. Okay, so now that we have our 2 binomials set equal to 0, we need to set each of these equal to 0 and solve for x. So I'm going to come off to the side since I ran out of room. I have x plus 1 equals 0. Minus 1 on both sides, I get x equals a negative 1. My other one was 5x minus 2 equals 0. Add 2 to both sides. I get 5x equals 2. Divide both sides by 5, and so therefore I get 2/5. So my answers are negative 1 and 2/5. In this one we see that we don't have a quadratic anymore, we have a cubic function here. So we have an r raised to the 3rd power. Don't start to freak out. You do have to notice that we do have a GCF. Again, it's the first thing that you should always check for. Do you have a GCF? In this case we do. We have an extra r in every single one of them. So I am going to factor out an r. So I get 4r squared plus 11r minus 3 equals 0. Okay. Don't forget this r needs to follow us all the way through the process. So r on the outside. Now we have a trinomial here, or a quadratic equation that we need to factor. Since the 4 is out front, we have to use the AC method again. So I have 4 times a negative 3, which again is a negative 12. I need to find factors of a negative 12 that will subtract out to 11. And in that case, it's a positive 11. So I have a positive 12x and a negative 1x will actually give me that positive 11x that we need in the center. So I'm going to go ahead and rewrite this as 4r squared plus 12x minus 1r minus 3 equals 0. Okay. Again, factor by grouping. I put an x instead of an r. Apologize for that. We need to factor out a greatest common factor, which in this case is 4r. Don't forget the r out front. It still needs to stay there. So I factor out a 4r. I'm left with r plus 3. Here I have a negative 1 that I can factor out. So I factor out a negative 1. I get r plus 3 equals 0. Get that in the whole screen. Okay, here we notice that we have a GCF of r plus 3, so I'm going to factor out an r plus 3. My leftovers are 4r minus 1, and that is all equal to 0. So notice here I have r plus 3, and I have 4r minus 1. I need to set all 3 of these things equal to 0, which is good because again we start out with a cubic function, which means there should be 3 answers for this. So I get r equals 0. That was the easy one. R plus 3 equals 0. If I subtract 3 on both sides, I get r equals a negative 3. So I have 1 answer, 2 answers, and then I have 4r minus 1 equals 0. Add 1 to both sides. I get 4r equals 1. Divide both sides by 4. And my third answer is 1/4. Okay, so again, 3 answers for this one: 0, negative 3, and 1/4. Okay, a little bit of a word problem here. Find the base of a triangle if the height is 3 feet more than twice the base and the area is 17.5 feet squared. Okay, in this question it refers to a triangle, its base and its height and area. So right away you should be writing down A equals base times height divided by 2, or 1/2 base times height. Either equation is okay to use. So again, we go back to the problem. It says find the base and height of a triangle if the height is, so we're talking to this one, so height is 3 more than twice the base. So that means that our base is our x, height is twice the base, so 2x plus 3, since it's 3 more than twice the base. Okay, it said that the area itself was 17.5. Okay, so plug everything into the equation that you know. So the area is 17.5, the base is x, the height is 2x plus 3, and it's all divided by 2. Okay, fractions are not our friends, so again, we've learned to use the shorthand or the shortcut for this. You can, again, only use the shortcut if you see an equal sign, which we see right here. So it's okay to multiply both sides by 2. So multiplying it by 2 here, that is going to cancel out. Do not multiply this through. I'm going to multiply by 2 here. So that reduces down to 35. I need to distribute this, so I get 2x squared plus 3x. Okay, so I have a constant here. I have 2x squared plus 3x. I need to get this 35 to the right-hand side. So I'm going to do that by subtracting. So I get 2x squared plus 3x minus 35 equals 0, of course. Then I need to go through and I need to factor this. Rewritten with a little bit more room. We need to factor this, so again we have to use the AC method. 2 times a negative 35 is a negative 70, so I need to find factors of a negative 70 that subtract out to 3. So that would be a positive 10 and a negative 7. So if we have a positive 10 and a negative 7, I do get that positive 3 that we need up there. So again, I'm going to rewrite. Positive 10x minus 7x minus 35 equals 0. Factor by grouping. Here I have a GCF of 2x, so I have x plus 5. I have a negative 7 that I need to factor out, so I get x plus 5 equals 0. So my GCF that I can pull out of both of these is x plus 5, and 2x minus 7 equals 0. So I need to solve for the x values here. So I have x plus 5 equals 0, minus 5 on both sides, and I get x equals a negative 5. 2x minus 7 equals 0. Add 7 to both sides. Divide both sides by 2. And I get x equals 3.5 because 7 halves is 3.5. So I have two values. I have a negative 5 and a positive 3.5. So I have to ask myself, this is a word problem based on a triangle, and is it possible for sides to be negative? And the answer is no. So again, we cannot use that x equals a negative 5. We have to use the 3 halves. So that means that this x is our base. Okay. So, or this was our base. Yes, this is our base. And then to find the height, you would substitute this back into the very beginning where we said the height was 2x plus 3. So 2 times this would be a full 7 feet, plus 3 would be 10. So that would be 10 feet, and this would be 3.5 feet. Okay. Okay, we have the Pythagorean Theorem here. It says that if you have a right triangle, then this statement is true. A squared plus b squared equals c squared. So this is referring to, again, a right triangle. these two parts right here are called legs. This is A, this is B. Technically, these can be interswitched. It doesn't matter which one A and B is. So go at it. I don't care which one you label A and B. But C is the most important part. C is the hypotenuse. It is always opposite the right angle, and it is always the longest side of the triangle. So please make sure that you are aware of that. Very, very important. So again, you can mix up A and B, but don't mix up C. Now, a lot of times where you'll see the Pythagorean theorem used is that they will describe like a television screen or a laptop screen, which is not triangular, but it is either a square or rectangle, most likely a rectangle. But the thing is a lot of people don't realize that when you buy televisions and when you buy laptop screens, they do not talk about the screens as in length and width. They talk about the diagonal measurement of the screen. So again, if it talks about a rectangular shape and the diagonal, this right here is your hypotenuse. So always the diagonal is the hypotenuse. So here's an example of where we would use the Pythagorean theorem. We have a right triangle here where the base is x, the height is x plus 1, and the diagonal or the hypotenuse is x plus 2. Again, a word problem might be that a rectangle has a base, an unknown base, and that the height is 1 more than the base and the diagonal is 2 more than the base. So this would be a setup for that type of problem. So because since we have a right triangle here and we're talking about the sides, we have to use the Pythagorean theorem. If we were talking about the angles, again, they would add up to 180, but there are no angles mentioned here. We just have sides. So we have a squared plus b squared equals c squared. So we need to substitute our sides into the equation here. So a, it doesn't matter which one. A, we're going to use as x squared. B, I'm going to use x plus 1. Now remember, when we're substituting something that is more than a monomial, you need to use parentheses. So I'm going to substitute this here as x plus 1 and then square it. So again, putting it into parentheses. C is our hypotenuse. Remember, it's always the side opposite the right angle. So it's opposite right here. So this is our C. Using parentheses, I'm going to do x plus 2 squared. Okay, so I've substituted everything in there. I need to simplify this, so I get x squared plus, now remember, this is the same thing as saying x plus 1 times x plus 1. So that is going to multiply or distribute out to x squared plus 2x plus 1 equals, same thing here, this is x plus 2 times x plus 2. This multiplies out to x squared plus 4x plus 4. Okay, so we need to simplify here. There are two x's here, 2x squareds plus 2x plus 1, so we combined like terms there, equals x squared plus 4x plus 4. Since this has more x squareds over here to the right hand side, we're actually going to subtract everything from the right hand side to the left hand side. So minus x squared minus x squared. So I get x squared. I'm going to subtract 4x, I get a negative 2x. Minus 4, I get negative 3 equals 0. So since everything had been moved from the right hand side to the left hand side, we get 0 on the right hand side. I need to factor this. Not too bad on this one because again, there's just a 1 out front. So I need factors of negative 3 that subtract out to 2, or negative 2. So I have a negative 3 plus 1 equals 0. So that means in this case, x is going to equal 3, and x is going to equal a negative 1. So again, since sides of a triangle can't be negative, that means that we're going to use the 3. So that means that this side right here is 3. This one is going to be equal to 4. And this one is going to be equal to 5. So again, 3 plus 1 is 4. 3 plus 2 is 5. Okay, this was an example that some students had some complications with last semester. So if the function is f of x equals 3x squared minus 11x minus 9, it says find all values for a when f of a equals negative 5. So the complication was that students were taking the negative 5 and sticking it in for a. This is not what it says. It says that the function equals a negative 5, or that the entire equation equals a negative 5. So again, I was seeing students sticking a negative 5 in here and a negative 5 in here and working it out. Not what it's meaning. So this is saying the entire equation or function is negative 5, which means I have to substitute it here, that the entire equation was equaling a negative 5. So negative 5 equals 3x squared minus 11x minus 9. I then have to move this over. So I get 3x squared minus 11x minus 4 equals 0. And then you need to factor from here to solve. So you will get a equals a negative 1/3 and 4. Meaning that when I stick a negative 1/3 into this equation, you will get a negative 5. Or if I stick 4 into this equation, you will get a negative 5. So be careful. This is saying again that the equation equals a negative 5, which means this, that the entire equation equals a negative 5. Okay, here we see that if we have something like this, where x plus 3, x minus 2 equals 0, if we see this here, this positive 3, technically when we solve it, it becomes a negative 3 because again we are subtracting that 3 to the other side. Same thing here with that negative 2, it becomes a positive 2. So technically all you have to do is think opposites. So if I tell you that I want x-intercepts, if I give you x-intercepts of 3, negative 7, I want you to find an equation where I have the parabola crossing these two spots. All you have to do is think opposite. So if I want a positive 3 as my x-intercept, that means that I'm going to stick it into a binomial as a negative 3. If I want a negative 7 as an x-intercept, I'm going to stick it into my binomial as a positive 7. So again, in order to do that, just think opposites. If I have an intercept at a positive 3, I'm going to stick it in as a negative 3, negative 7, stick it as a positive 7. Now if I want to find the actual equation of that, you multiply it out completely by using distribution. We get x squared plus 4x minus 21 equals our function, or our equation.